Dear friends, as you may know, Mass Aspirants is a vibrant community of students who pursue higher mathematics, and we used to organize several programs to facilitate their preparations for higher mathematics. And we used to organize online problem solving sessions. Today, we blessed to have Dr. Himanshu from IIT Delhi with us to handle a session on ordinary differential equations. This is actually the second part of the previous session, which was held on August. Today, he will discuss more problems from the ordinary differential equations part from the IIT JAM syllabus. Also, he will discuss some problems from CSIR, NET and GATE as well. I'm sure that today's session will be really beneficial for those who are seriously preparing for this type of exams. I would like to express my thanks to Dr. Himanshu for being with Math Aspirants. Dr. Himanshu did his master's from IIT Jodhpur and completed PhD, and recently awarded PhD from IIT Delhi. So I welcome everyone to this problem solving session. Welcome, Himanshu.
Thank you, Vinod sir, for inviting me for this session. So again, it's a nice experience whenever I am presenting my work. So I got to know many things for myself as well. So before starting, so this session will be like I want you to be part of the discussion in this session. So let's start it. So in this session, I have almost all the theory that we have needed, like the questions that we will cover here. So we have all the theory covered in this session. So in case if you have like not studied or you are not revised your theory part, so we will cover it here. So in this session, we will cover the second order ODE because in the last session we covered the first order ODE. So maybe in the upcoming session, we will cover the questions based on system of linear equation and Sturm-Liouville problems. So let's start this question. So as I said, so there will be three things that we will cover. So linear differential equation. So we will talk about the solutions. We will talk about the linearly independent, the questions based on the Wronskian, and how we will compute the particular and complementary solution of the linear differential equation. So as we know, the linear differential equation. So this is the general form of a linear differential equation. When the coefficients are constants, then we say that this is a linear differential equation with constant coefficients. When gx is 0, the right hand side of the differential equation, then it is called a homogeneous solution. And when gx is non-zero, then it is a non-homogeneous differential equation. So we found these solutions in the form of when we solve the differential equation in the form of a complementary solution and a particular solution. This I will define in the upcoming slides as well. So the right hand side is 0, then the differential equation is a linear homogeneous ordinary differential equation, and when gx is non-zero, then we will have a non-homogeneous linear ordinary differential equation. So particularly in this session, we will be more focused towards the second order linear differential equation. So the second order linear differential equation is of this form: a naught x d square y by dx square plus a1x dy by dx plus a2xy equals to gx, where a naught x will be the non-zero. So we are assuming that these functions ai's are continuous in some domain D. Now we will define the if y1x and y2x are two solutions of the differential equation, then these solutions are said to be linearly independent if we take a finite linear combination for two solutions. We have c1y1x plus c2y2x equals to 0, then c1 equals to c2 equals to 0. That means we have a trivial solution of the linear combination of 0. Note that here we are taking y1 and y2 are two functions. So this holds for all x. So I have taken an example y1 equals to e raised to the power x and y2 equals to e raised to the power 2x. So one can check that this is a linearly independent. So can you tell me how you will check whether this is linearly dependent or linearly independent?
Just dividing
Yeah,
this
we
two.
check by the determinant form. If we take y1 and a okay, determinant met is not.
Yes.
Just dividing we get uh, e raised to xi.
Sorry.
Y1 divided by y2 we get 1 by e raised to x. Then it is not a constant. Therefore, it is linearly independent.
Find the Wronskian of this function.
Okay. So will the Wronskian always work? Yeah, finding Wronskian is one way of doing it.
If we can define y1 in terms of y2, then it is linearly dependent, otherwise it is not.
Okay, so let me show you. So I'm not able to write it here. So maybe I will open my slides in another application. So just give me a moment here, please. Okay, so we are on this question. So here I have asked, so let's use the definition. We have C1 e raised to the power x plus C2 e raised to the power 2x equals to 0. So we have to show C1 and C2 are 0. So one way of doing is it differentiated C1 e raised to the power x plus 2 C2 e raised to the power 2x equals to 0. Then this is a system of equations. So we can solve it and can see that C1 and C2 are 0. So this is one way of doing it. Another way of doing is it take the particular value of x, say x equals to 0 and x equals to 1. Then solve the equation and say C1 and C2 is 0. So can we go further?
Yes, sir.
Yes,
Okay then. Okay then. So now there is a theorem which is principle of superposition. So in this, if we have a nth order linear differential equation, and if yi's are the solution of this differential equation, then the linear combination of yi's is also a solution of differential equation if and only if either gx is 0 or summation ci is equals to 1. So it's very obvious when we are taking gx equals to 0, then this linear combination is a solution. Why we are taking this condition? Can anyone tell me? So this condition that we are taking, why? Here note that we have on the right hand side gx. When gx is non-zero, when we substitute this yx, then in that case, after substituting, we will get on the right hand side as if we substitute yx equals to summation ci yi in the given differential equation, then we will have summation ci gx on the left hand side. So after substituting, we will get this. To make it equal to the right hand side, we need a condition. This ci to be summation of ci to be 1. That's why we are having a condition summation of ci equals to 1 here. Okay, let's understand this from some question that we have it. So this is again I have defined it here. So here is the question for you. If y1x and y2x are solution of the differential equation given by this, then which of the following is also a solution? So tell me which one option will be correct here. So more than one option can be correct here. Yes, anyone?
Option C.
Option C, okay. Yes, so option C is correct. Why option C is correct? Can you explain?
Because we have y1x and y2x solutions, and
Yes,
in option C we have coefficients 2 and -1. 2 plus -1 is 1, so we have sum of Ci as 1. So by the previous theorem,
correct.
our
Why
C is
option?
solution.
Why option A? Why it is not correct?
In option A, our uh, sum of coefficients will be 2, and so not equal to 1.
Okay, fine. So just see here whether this is a homogeneous differential equation or a non-homogeneous differential equation.
Non-homogeneous.
Is it?
Mhm.
Yes, what about others? See, here note that I
It
have
is
on the right hand
homogeneous.
side y as well. So I can take my right hand side part here, so this part on the left hand side. So this differential equation will become homogeneous. So this is a homogeneous differential equation. So for homogeneous differential equation, my only linear combination of yi's will be the solution, right? So even I substitute this solution in my differential equation, this will satisfy the solution. So here my all options are correct. Is it fine?
Yes, sir.
So make sure that when you are seeing on the right hand side, there will be no term of y dash and y double dash involved. So it will purely be a function of x only. So this is the explanation I
Sir,
have given here.
sir,
Yes.
can you repeat? I did not understand how all options are correct.
Okay. So here note that this differential equation is homogeneous differential equation. Is it clear?
Yes.
So this is a homogeneous differential equation because we can take right hand side on the left hand side and make it homogeneous differential equation. And we know that for homogeneous differential equation, any linear combination of solution is also a solution.
Okay.
All the functions here in the options are linear combination of y1 and y2. So that's why all options are correct.
Okay, got it.
Okay then. So here is the explanation I have given it here. So you can see it later also. Now let's go to the another question. So we have three solutions y1, y2 and y3. So tell me which of the following are general solution of the differential equation. Yes. So here I have said that which of the following are general solutions of the differential equation. So we are not given any differential equation. So we are given only the solution of second order non-homogeneous linear differential equation. So we are given it is non-homogeneous. So but we will see it here.
Summation of CI is 1, then it will be a solution. So first option is correct.
Correct. What about others? Is it clear? So if any step, if it's not clear, then please stop me at that moment. I will explain it, then we will go further. Okay then. So we can check it here, the coefficients of CIs in all the options.
So coefficient of CI is
So
1.
first what we will do it here. Yes. So for example, in first option, we have C1 plus 1 coefficient of Y1 plus C2 minus C1 minus C2. So the summation of all the coefficients of Y1, Y2 and Y3 is 1, right? So when summation of Ci is equals to 1, this is called a convex combination of Ci's. So we will check the convex combination of all the coefficients of Y1, Y2 and Y3 is 1 or not. So in option 1, convex combination is 1. In option B, it is not 1. In option C also it is not 1. In option D also you can check that it is not 1. How you will do that in option C? First you will write the coefficients in of y1, y2 and y3. So what we will get it here? C1 plus 1 y1 plus minus C2 of y2 plus C2 minus C1 of y3. So add it. C1 plus 1 minus C2 plus C2 minus C1. So this is coming out to be 1. So hence option A and D are correct. Okay then, let's go further. So now what we will define is Wronskian. So for any nth order linear differential equation, we define the Wronskian in the term of its solution as a determinant of a matrix which is given by y1, y2, yn and its derivative later on, which is y1 dash, y2 dash, so on yn dash, and we will go to its n minus 1 derivative. So we know that these are the solution of differential equation. Hence, this derivative of this yi's will exist and will be continuous. So the Wronskian will always be a continuous function, right? This is a continuous function and differentiable also, because we know that the derivative till nth order will exist. So always Wronskian is a continuous function and its derivative will always exist. So why we will study Wronskian? So there are many properties. One of them is finding whether the solutions are linearly independent or not. So for second order ODE, we define the Wronskian as y1, y2, y1 dash, y2 dash, the determinant of this. So we will have y1, y2 dash minus y1 dash, y2. So what is Abel's formula? Abel's formula for Wronskian is Wronskian of y1, y2 is a e raised to the power minus integration of a1x by a naught x into dx. A note that a naught x is always non-zero, so this formula will exist. So what we can conclude from this Wronskian? We can conclude that so this is some function, say a e raised to the power px. So this will always be a positive function. So now the Wronskian depend on this coefficient a. So from this we can conclude that Wronskian is always identically zero or never zero. So many of the questions will come on this property only. So there are many questions based on this property that we will see that. So from this we can conclude either the functions are linearly dependent, linearly independent. We can talk about the solutions or the roots of the solutions of differential equation. So these are the important observations on the Wronskian. So if Wronskian of x is 0 for some x, then y1 and y2 are linearly dependent. If Wronskian of x is non-zero, then y1 and y2 are linearly independent. Also, again, from the definition of Wronskian, if y1 and y2 has a repeated 0, then these are linearly independent because Wronskian will be 0 in that case. So I'm saying if y1 of x naught equals to y2 of x naught is 0, then we can compute the Wronskian at x naught, then Wronskian will be 0. That means the Wronskian will be identical 0 from our first point. Similarly, if we talk about the converse, so linearly independent solutions have no common zeros. So if y1 and y2 are linearly independent, then they don't have any common zeros. So based on this, many questions have been coming to past also. So we will have some questions in our slides as well. So this is one example based on the Abel's formula. Here we have a differential equation y double dash minus 2y dash plus y equals to 0. So we are given y1 of 0 equals to 1 and y2 of 0 equals to 1 and Wronskian of 0 equals to 2. So we have to compute Wronskian of 2. This we can directly compute using Abel's formula. So I'm not doing this question. This question you can do it on your own also. Now we have another question. So you have to tell the answer of this question. So we have a second order linear homogeneous differential equation where a naught x is non-zero and ai is x are continuous function of x. And if we have y1 and y2 are two solutions satisfying y1 of 0 equals to 0, y2 0 equals to 1, y1 dash 0 equals to 1, y2 dash 0 equals to minus 1. Moreover, we are given that y2x is not 0 for all x, and we define another function gx equals to y1x divided by y2x, then which of the following is true? So gx is strictly increasing, gx is strictly decreasing, gx is constant, gx has a point of extrema. I hope you know the meaning of gx as a point of extrema, right?
C.
So, sorry,
Sir, C option. Sorry, B
Gx is a
option.
constant.
so can you repeat again, please? Which option is correct?
सर हमारा बी आ रहा है
B आ रहा है. Okay, what about others? Okay, so how you will do that? First tell me. Yes, how this question can be done? Yes, how you are getting option B? Any guess? Okay, how you check whether Gx is strictly increasing or strictly decreasing? What is the process of checking this? Okay, what if G dash X is greater than 0? Then what we can say about G?
Increasing function.
G is increasing function, right? So let's compute the G dash X. So what is G dash X here? Y2 Y1 dash minus Y1 Y2 dash divided by Y2 square, right? So what is this? The numerator part. This is minus of Wronskian, right? Is it clear? So here also I have done this. So Gx is this, G dash X is Wronskian of Y2 X square. Is it clear?
Yes, sir.
And we have computed that Wronskian is negative and denominator will always be positive. And we know that Wronskian always keeps the same sign because that depends on the constant A only. So it will always be negative. That's why Gx will be strictly decreasing. So option B is correct. Any doubt in this question? Okay, if not, then we will proceed further. So there is one more question. So this is a CSA net question. It's a very easy question.
Sir,
So we are, yes,
we got Wronskian as -1, right?
yes,
And our G dash of X is minus Wronskian by Y2 square. That will be 1 by Y2 square, right?
let me check again. Maybe I have made some calculation error. So we have Gx is this. So we will compute G dash of X, which will be Y1 dash into Y2 minus Y2 dash Y1 divided by Y2 square. What will be the Wronskian? Y1 Y2 Y1 dash Y2 dash, which is same as Y1 Y2 dash. So it will be minus of Wronskian divided by Y2 square. So I have made a mistake in writing here. So it will be negative here. So also in downward also some mistake is there. So it will be Gx is strictly increasing. So here I have made an error in this, so please rectify it. Yes, thank you for correcting me.
Okay, sir.
Okay then. So we have an ODE U double dash T plus PT U dash T plus QT UT equals to RT. So here in this question, we are given a Wronskian. So the question asks which of the following options are possible.
Option D is correct
So
option.
option D.
Option D
Yes,
is a correct option.
option D is correct, bro.
Why option A, B, C are not correct?
Because Wronskian is identically zero or never zero.
Yes. So when it never zeros, then it keeps the same sign. So these are the two properties. So here we can see that this is not identically zero, right? For t equals to 1 by 2, it is 0, and for another cases, it is non-zero. So the other way of checking it is changing the sign from positive to negative or negative to positive when we are going from 0 to 1. So from these two ways, we can conclude that option A, B, C are not possible. So only option D is correct, right?
Yes,
Okay,
sir.
so this is an easy question. This is an easy question. So there is one more question on Wronskian. Let P be a continuous function on R and W be the Wronskian of two linearly independent solutions y1 and y2 satisfying the given differential equation. If Wronskian of 1 is A, Wronskian of 2 is B, Wronskian of 3 is C, then which of the following are true? Yes. So how we will do this question?
Using Abel's formula.
Yes, the one way of doing is by Abel's formula. Then we know already that Wronskian is always either it keeps the same sign, right? So there is no need of computing Abel's formula here. So even without computing Abel's formula, we can do this question. See, we know that Wronskian always keeps the same sign. Either it is 0, it will be always positive, or it will be either negative. So option A is incorrect. Can we tell directly from here,
Yes.
right?
Yes.
And option C will always be correct. This also we can see because A, B, C are either all positive or all negative, right?
Yes.
Now how we will check option B and D? Yes.
So either the value is increasing or decreasing. So option B is the correct one.
Correct. So how you said that this is increasing or decreasing? Is it clear that the Wronskian will always be either increasing or decreasing? Is there any question in that?
Wronskian can be constant also.
Why D option is not correct?
see here, note that in all the option B and D, A and B are either greater than 0 or less than 0, right? So for
Yes.
option B and option D, we will compute the Wronskian of the given differential equation. How we will do that? So we will use the Abel's formula here. So using Abel's formula, we will get our Wronskian as this. So note that this will always be a decreasing function, right? So our Wronskian will depend on this coefficient C. If C is positive, then Wronskian will be decreasing function. If C is negative, then Wronskian will be increasing function. So using these two things for A, B and C, we know that Wronskian is strictly increasing and strictly decreasing. So it will never be a constant function. So A, B, C are never 0. We can say directly also, because we are given y1 and y2 are linearly independent solution. Is it clear how we have done this? Yes, no, anything?
Yes, sir.
More or less, we will compute the Wronskian of y1 and y2. Then we will check at the coefficients. And then we will say that this function is increasing or decreasing. Okay, so let's go further if you don't have any question. So now we will talk about the analysis of the set of zeros of non-trivial solution. So these properties, we got it using the Wronskian. So we will not see the proof here, but it will be very clear from the statement only. So if we have the second order linear homogeneous differential equation where ai's are continuous and a naught x is non-zero, then we will consider the set A, which is the zero of all the non-trivial solution of yx. Then what we can say about A? If there exists x naught belongs to A such that y dash x not equals to 0, then yx is a trivial solution. Why? Because if y dash x not equals to 0, then Wronskian will always be 0, and we can see that it will always be a linearly dependent solution. So this is one of the intuition here, that from that you can understand this statement. Similarly, if yx is non-trivial, then every element of A is an isolated point. And A is a countable set. A cannot be bounded infinite set because if A is bounded and infinite, then yx must be a trivial solution. These all properties can be solved using Wronskian property. Some are based on Sturm-Liouville theorem, so I am not going into that. So many questions comes directly based on these statements only. Now, if we have y1 and y2 are two linearly independent solution of the differential equation, if A is the set of zeros of y1 and B be the set of zeros of y2, then A and B have no common zeros, because if A and B are common zeros, then their own skin will be 0. Then the solutions y1 and y2 will not be linearly independent. So statement 1 is a trivial statement. Similarly, using that, we can say that they don't have any common zeros and common extrema as well, because if again they have common extrema, then their own skin will be 0, then the solution will not be linearly independent. From the last results, we can see that every point of A and B is also an isolated point. The cardinality of A and B are countable. So this is one of the statement that generally comes as it is in the options as well, which is between any two successive zeros of y1, there is exactly one zero of y2 and vice versa. So if cardinality of A is greater than equals to 2, this implies cardinality of B is greater than equals to 1. If cardinality of A is greater than equals to 3, then cardinality of B is greater than equals to 2. That means there lies a extrema in between them because of mean value theorem. If A is finite, then B is finite, because if one of them is infinite, then there is always a 0 between two consecutive root of A1, implies B is infinite as well. Now consider this differential equation y double dash x plus qxy equals to 0. So here qx is less than 0 for all x belongs to R, and let yx be a non-trivial solution. Then in this yx has at most 1 0, yx not equals to 0, then yx is strictly monotonic. So if there is 1 0 of the solution, then it will be either strictly increasing or strictly decreasing. If yx not equals to 0, then y dash x is never 0, because our function is strictly increasing or strictly decreasing. From point B, point C, we have got it. That implies yx either goes to infinity or yx goes to negative infinity, depending on the slope at x naught. Now when qx is positive for all x and qx is unbounded, area under the curve qx is unbounded, then yx has infinitely many zeros on positive x-axis. Yx is non-monotonic because this has infinitely many zeros, right? Limit yx does not exist. Similarly, limit of its derivative at infinity does not exist. So these are some of the important results that I have mentioned it here. I have seen that in the past years, many questions are directly based on this. So let's have a question on this. So if y1x be non-trivial real solution of y double dash plus x yx equals to 0, and let y2x be the solution of y double dash x plus yx equals to x square plus 2, then which of the following are correct? Yes, please see that and tell me which options are correct. Okay, what we can say about y1 and y2? First, tell me what we can say about y1, whether it has infinitely many zeros or finitely many zeros. Here, what is qx?
So
qx
y1
is
has
x.
infinitely many zeros and y2 has finitely many zeros.
Why y2 has finitely many zeros?
because y double dash plus q of x into y equal to 0, that is nothing but q of x is greater than 0. The value should be greater than 0. The solution has infinitely many zeros.
Okay, what we can say about y2?
So y2 we will get a finite solution. We have to find the particular solution and also complementary function.
Yes, we cannot apply the result of above here because here this is a non-homogeneous equation. So in that case, for y2, we have to compute the solution. So we have to compute the complementary solution and particular solution. And from that, we can see that y2x has finitely many zeros. Okay, so let's go further. So now what are linear differential equation with constant coefficients? A linear differential equation of order n with constant coefficient is of this form, where ai's are constants and a naught is non-zeros. So here I will go little fast. I won't give all the theory here. So there are many ways of finding the particular solution. For finding the complementary solution, we will form a characteristic polynomial by substituting a solution e raised to the power m max, and we will get this equation as the characteristic polynomial or characteristic equation or auxiliary equation of this differential equation. So we will found the root of this equation, and then based on these roots we will say that our function, our solution will look like this. I hope this everybody knows. So if someone don't know, then please stop me here. Now for finding the general solution, so we will find the particular solution as well. So there are various ways of finding the particular solutions. So there is one way which is called method of undetermined coefficient, and the second way is method of variation of parameter. There is another form also which generally we will use it as a trick also. Sometimes that depends on the right hand side. So now in this session we will cover the method of undetermined coefficient and method of variation of parameter. So meanwhile, if some special expression will come, then I will explain that also. Otherwise, it's very easy that we can do it on our own also. So whenever our expression is of the form e raised to the power kx sin bx cos bx polynomial or any other function, then in method of undeterminate coefficient, we will assume a function, and based on that we will find its particular solution. So here there is a remark here: if our gas overlap with the complementary function, then we will multiply by the least power of x on the gas. So these are some of the gas. So for any polynomial of degree n, this will be our initial gas. So if in the complementary solution, if there is any polynomial term, any monomial term of say x raised to the power m, then we will multiply our gas by least monomial so that our initial gas won't contain that term. So there is a question that I have kept it here, so I will ask that also. So in this initial gas, we will cover, for example, we have sin bx and we have a differential equation of two order. So as our initial gas, we will take the linear combination of this function and its all possible derivative that can occur. So for sin bx and cos bx, this will be our initial gas. So for this, we will have a polynomial. Since the polynomial and its derivative are of least degree, so this will be our initial gas. I hope this is clear.
Yes,
So
sir.
this is one of the example. So this is the given differential equation. We can find its complementary solution. So the auxiliary equation of this is given by this. We compute its roots. Its complementary solution is c1 e raised to the power x plus c2 e raised to the power 2x. Then we can make a guess of e raised to the power x. Since e raised to the power x is in the complementary solution, we will multiply by least common multiple, which is x here. So our initial guess will be ax e raised to the power x here. Note that this is e raised to the power x. We have in our complementary function as e raised to the power x here. There is another way of doing it. If we write the differential equation in the operator form, which is d square minus 3d plus 2y equals to e की power x, then we see, if we say this is a function fd and we compute it on 1, which is the coefficient of x here, then from that also we can compute it. So these are given in many books. If you want to know that, maybe next session I will do some questions based on that. So this I will ask it at the end of the session whether you need it or not. So most of the questions generally in this area, like for example, you have to find the complementary solution or particular solution. So the best way of doing this type
How
of
to
question
choose
is,
A equal to 1?
so whenever we have our differential equation of this form, say fd of y equals to e raised to the power ax. So we take the coefficient of x. Here it is a. In our question, it is 1 only.
Okay.
This question needs practice, but I have seen like in last couple of years, no questions are coming from this area. So that's why I have skipped it. But in case if you want it, you can message me, then I can send you the notes on that. So you can try the questions based on that. But I suggest that most of the questions on this, you can directly do it with the help of options only.
Sir, in case of
Okay, so
finding particular integral, it is quite difficult for me. Using complementary to find out complementary function quite easy, rather in respect to finding particular integral.
yes,
And for
yes,
some,
this is true. Like fine.
especially
Yes,
if
this is
we
true. Like,
use the operator method, I mean, in terms of d, uh, in then I feel some difficulties in, except it is
yes,
some typical function, exponential or sine or simple cos. Uh, others For others it is quite difficult, and calculation would be
yes,
good lengthy.
yes. For this only, like for a particular type of right hand side, we have a different kind of technique. So there are three kind of techniques generally that I use it. So one way of doing it is via method of variation of parameter. So this is the approach that mostly I will apply first. The second one is method of undetermined coefficient, and there is another approach also that varies depending on the right hand side. But as a competitive exam point of view, like most of the questions can be done simply by looking at the options, right? But still, if you want to understand, then I can share you the notes later on, so you can study from that part.
Okay, sir.
Yes. So for variation of parameter, if for this, if we know the complementary solution, say y1 and y2 are known, then we can find the particular solution using this formula. Everyone knows this, so I'm going a little bit fast here so that we can cover most of the questions that I have written it at the end. So this is the question based on the variation of parameter. So here our right hand side is e raised to the power x. So we can found the two solutions of the complementary solution as e raised to the power and e raised to the power minus x. Then we can compute the particular solution by directly substituting the formula, which will come out to be e raised to the power x by 4. Okay, so now let's go to the Cauchy's homogeneous linear differential equation. So generally, particularly in IT jam, I think one question definitely comes from here. Like I have noticed here, like one question, most of the time they will take from Cauchy's homogeneous linear differential equation. So what is Cauchy's homogeneous linear differential equation? A differential equation of this form. Therefore, note that for every nth order derivative, we have a multiple of x raised to the power n. So for any ith derivative, its coefficient will always be a constant into x raised to the power I. So this type of differential equation is called Cauchy's homogeneous linear differential equation. So such type of differential equations can be solved by substituting x equals to e raised to the power t or t equals to log x. So when we will do the substitution, then our differential equation will convert it into this form. So we will replace our differential equation by this operator, and then this differential equation will be converted into a differential equation with constant coefficients. So here I have mentioned it, the technique how we will do that. So let's see a question based on the homogeneous differential equation. So this is the question that came last year in IIT JAM. So here we will do the substitution. So we have a Cauchy-Euler differential equation given by x square y double dash minus 5x y dash plus 9y equals to 0. So our differential equation now, it will convert into d into t minus 1 of y minus 5 into t minus 1 So we do the substitution x equals to e raised to the power t plus 9 equals to 9 y equals to 0. Then after solving this, we will have it d square minus 6d plus 9y equals to 0. We solve this differential equation. And then again, substitute x equals to e raised to the power t, and we will get our solution. Is there any doubt in that? So the solution, I have written it here in more detail. So we solve the differential equation, and then later we substitute it back it here, and we will get this as our solution. So here I have a remark here, like most of the times I have seen my friends also, they at the end they forgot to substitute it back. Because of that, they sometimes got it a wrong answer. So please make sure that after computing the solution, you will substitute it back and then compute it. So this is another question of IIT JAM 2025. So here we are given a linear differential equation with constant coefficient. and on right hand side we have 2e raised to the power 4x. So this is the same question that we have done back also. So this I am skipping it here. This you can do it on your as homework. So this is the solution. So you can verify that option A is correct. So this is a nice question. So here in this, let V be the set of all bounded solution of the ODE given by u double dash t minus 4u dash t plus 3u2 equals to 0. So in this question, we talk about the dimension of the vector space V, or particularly about the V. So tell me which of the following option is or are correct. Yes, before proceeding further, can anyone tell me how you will solve this question? I just want to know your approach, how you will do that. So we are talking about bounded solutions, right? So we have to compute the solution, at least this is clear. So what will be the solution of this differential equation? So auxiliary equation will be m square minus 4m plus 3 equals to 0. So what are the roots of this?
1 and 3.
So 1 and 3 are root of this. So our solution will be C1 e raised to the power t plus C2 e raised to the power 3t. Right? So what is our set V? V is the set of all bounded solution. So when this function ut can be bounded?
T is negative.
Will it be bounded? Okay, what about function e raised to the power t?
Unbounded function.
Unbounded function, it is always strictly increasing. Similarly, e raised to the power 3t also. So either coefficient C1 are positive or negative, it will always be increasing or decreasing function. So ut can be bounded if and only if C1 and C2 are 0. Is it clear why we are taking C1 and C2 to be 0? So we got only option C as our correct option. Hence option A, B, C are A, B, D are false. So this is the explanation. I have written it here. Now there is one question based on CSI and NET. So in this question, we consider a differential equation x square y double dash minus 2x into x plus 1 y dash plus 2 into x plus 1 y equals to 0. So if a polynomial is a solution, then the degree of the polynomial is equals to yes. So we are given a polynomial is a solution of this. So we are talking about the degree of polynomial. I hope everyone knows the definition of a degree of polynomial. If someone don't, then please ask me, I will explain. Any guesses or any hints how we will do it? Yes. Anyone? Okay, what is given to us? So we are given a polynomial is a solution of the given differential equation. So we can always assume a polynomial. Say our polynomial is px some am x raised to the power m plus am minus 1 x raised to the power m minus 1 plus so on. Right?
Answer A.
Sorry?
A.
Yes, option A is correct. Now you got it?
Take polynomial of degree 1. Linear function.
Yes. So from options, it is clear that our polynomial is of maximum degree 4. Okay. So here we can take a monomial also. We can take am x raised to the power m or x raised to the power m also. Right? So take this and substitute in the differential equation and compute the value of m here. So you will get it m to be 1 here. So when something they have talked about the degree of a polynomial, always consider one expression of a polynomial and then use it and then find the solution from this. Don't need to take every time this here and make your calculation hard. So try to do it with the simpler case and proceed from that. Okay, so let's go to the another question. So this question is based on Wronskian. So in this question, we are considering the second order ODE x double dash plus pt x dash plus qt x equals to 0. If x1 and x2 are two solutions, then which of the following statements are true for the Wronskian? That Wronskian equals to 0 in AB implies that x1 and x2 are independent. Wronskian can change the sign. Wronskian is 0 for some point t naught in AB, then Wronskian is always 0. Wronskian is 1 for some t naught, then Wronskian is 1 in AB. Yes. So many properties we have done earlier also in the session. So please tell me what will be the answer. I don't think so you will take that much time for solving this question. Yes.
CT.
Option C is correct. Obvious from the points that we have done earlier. Option A is false. Option B is also false. Why option D is correct? Why option D is correct?
Wronskian is either identically zero or
It will be a function, right? So you can
yeah.
take any example. Say you have an solution as e raised to the power x and another solution as e raised to the power 2x. Or you can take any other example and then check it whether the another way of checking it is you can take solution as y1 equals to x and y2 to be x square. And you can check that at some point it is 1, but another point it can be any other value, right? Okay, let's go to the another question. So this question I have put it here, like we are given the solutions here. y1x is 1 plus x and y2x is equals to e raised to the power x. Then we are talking about this constant px, this coefficient px. So how you will compute px when two solutions are known? So this question came in CSIR net. Yes. I think similar kind of thing we have done in one of the questions that we have done. So how we will proceed? Here we are given only solutions of the differential equation.
Using Abel's formula can be.
First we calculate Wronski and then Abel's formula, then we will compare px, I think.
Yes, so this is how we will do it. There is one more thing that we know, if you remember the Abel's formula, like how we compute the Abel's formula, then we got this one of the differential equation. So in particular, for any differential equation of this form, we can always reduce it to this differential equation. So in this case, in this differential equation, our differential equation will reduce to this. And then using this, we can compute the Wronskian of y1 and y2. We can compute its derivative and then find the Wronskian here. So this is what I have done it here, and you can verify using this that option D will be a correct option in this case. Also, there is one another way if you will check it. You just compute the Wronskian and verify from the solution also. If you don't remember this formula, what you can do is take the options and then using Abel's formula, find the Wronskian and find the Wronskian from here and then verify which option is correct. In case you don't know the formula, so you have another methods to do this question. So always make sure, sometimes it is better to go in exam through the options only and then verify whether which option is correct. So this is it from my side, sir. So I hope this session will be useful to all of you guys. So if you have any questions, then please ask.
Okay, thank you, Himanshu, for this nice session.
Thank you, sir.
Okay, now let us move to the feedbacks. I think you may turn off the presentation. So dear participants, feel free to share your comments and feedback.
Hello, sir.
Yes.
Hello.
Sir, good evening. So I'm Archana. I have completed my BSc and I have taken a drop year for JAM. So I really enjoyed your class, and I actually have done OD to an extent, but a lot of points I thought I had covered somewhat of the portions, but a lot of points were missed. So I realized that because of your class, and I understood how each concept you have applied in a question. It was not too basic level or too tough level, but it was a really nice class. I enjoyed the class. So hoping more classes from your side. And sir, could you please share the PDF?
Sure, I will share it to the sir, and then sir will share it further.
Okay, sir. Thank you, sir. Thank you, Vinod, sir, for organizing the class.
Yeah, thank you, Archana.
Hello, sir.
Yeah, yes.
Uh, I am Sneha and I have completed my master's. Now I am preparing for CSIR NET and GATE. So, first of all, I want to say that thank you for the session, and this session is really good, and I am expecting more session, at least one or two more session for CSIR and GATE PYQs for this topic, if possible. And I have already studied OD previously for JAM, but the thing is, this in the today's class, what sir has explained, undeterminate coefficient for finding PI, always forget these methods, variation of parameter, and whenever in the exam I see those questions, I skip just because of method. I used to forget every time. So today everything again I remember, and it was very helpful session. Sir has explained everything step by step and details, so I cleared my all the doubts. Yeah, thank you again. And yes, please take one or two more sessions on this topic.
Yeah, sure, Sneha. We will try to arrange more such sessions.
Thank you, sir.
Yeah, one more thing from my side also, like
Sure.
Yeah, actually, the syllabus that I have seen, like you also shared it. So in that, most of the things we have covered it, but for CSI net and GATE particularly, many things are remaining. So at maybe one more session, definitely that will be based on Sturm-Liouville value and system of linear differential equation. Actually, in this session also, I was planning to have more questions on system of linear of differential equation, but later I thought just keep it till JAM syllabus only. So maybe next session, particularly for CSI net and GATE aspirants, it will be very better.
Yeah, we can include more problems from CSR net and GATE in coming sessions.
Yes.
Actually, Himanshu, in the chat box, Dharmendra is asking about your research experiences. Yeah, it will be good if you can share your research experiences in IIT Delhi. That may be really motivation for PG students to pursue for research.
Yeah, it's always a like being into research is always a nice experience. You learn too many things. Apart from studies, also you learn too many things. You are not restricting only to studies only. Like you growth mentally, and you learn a lot of experience, patience, a lot of things you will learn. Your way of thinking is will also change when you will come into a research. So again, the word itself says research, re and search it, again do it and do it. Then the way then you do find something new will make you to go deeper and deeper. You will ask questions, whatever the things that you are studying. Okay, you are reading something, then how the statement will come, why we are adding this word, why this condition is added and all. So it will always be a good experience when you will study something. So yes.
Okay, thank you, Himanshu. Some more feedbacks are there in the chat box.
Thank you.
Yeah, thank you, Dharmendra. So any of you would like to make any comments? You can make it now. Otherwise, we will formally wind up the session now.
Can you tell some books also, except Kirtana series?
You can you can take any book, but the thing is you need to practice a lot of questions. So in my session also, I have put too many things. So you can consider too many things are also have shared it, and too many other people have shared it in the group. This is more than enough. So consider any book, just read the theory part, and then after reading part, you do as many questions as you can do. Because during exam only doing questions or your practice will help you.
Yes, sir. Yes, sir. Okay. Thanks, sir.
Yes, sir.
Yes.
Sir, I am Supratim from West Bengal. I am taking a drop and I am aspiring for appearing JAM this year. And this was my second session with you. I have a very earnest appeal to you to share those notes for JAM syllabus only, because I have done with some book in the semester, but there are problems starting for me finding the non-homogeneous, finding the particular integral of non-homogeneous equation and method of variation of parameter and undetermined coefficient. This, if you kindly share this note, and I will go through, because I think I am not capable of learning this thing from the book itself, particularly this topic. And please, sir, thank you for
Yeah, sir. So how
session
we
and
can share it? Like maybe I can share my mail ID or WhatsApp number. So what will be good? Like how we can do that?
Okay, sir. Okay. Okay. And I have requested many times, Vinod sir, to organize a session, and very thank you from bringing time out of your busy schedule, and thank you. And you have explained through continuously and with the moderate level of speed. It is good, very good.
Yes, there is one more feedback from my side also. Sometimes I need to revise also. I see many sessions, many experts have covered a very good syllabus in sessions. So I strongly suggest you, if you need some material, some notes, quick notes, then go through these sessions that sir has organized for us. So it will be very helpful if you go through from that sessions. So you will get very quick notes, good questions, quality questions. So this is one advice from myself also. This is what I have experienced for mine also.
See, actually, yeah, in our group, we are sharing almost all the materials required for preparing any of these kind of exams. So remember that the only way to clear these exams is practice, more and more problems. So for that, try to attend this type of live sessions. That will certainly will give you a classroom feeling, and will get a flavor of peer learning. All that will be really helpful. So thank you, Himanshu, for this session. And please share me the PDFs that you have mentioned, of today's session. And also, I think you mentioned that some PDF regarding with solution by variation of parameters, something like that. If any of that type of things are there, please do share it with me. We can share it along with the recording of this class.
Sure, sir. I will do it today only. I will share it to you.
So once again, thank you, Himanshu, and thank you all the participants. Wish you, Himanshu, wish you all success in your academic career. And for the participants, we wish all the participants a great success in the forthcoming exams. Thank you. Thank you, everyone. Let us wind up here.
Thank you, sir.
Yes,
Thank you, sir. I'm grateful to you for arranging so many beautiful and engaging videos for us.